Today we learn the difference between one-tailed test and the two-tailed test. So one-tailed test and two-tailed test are the different ways of testing the hypothesis. These are not a type of test, but these are the ways to test, to perform the hypothesis testing. So what is a one-tailed test and what is a two-tailed test? We explain this using the difference. Alternative hypothesis is one-tailed, either left or right. And the alternative hypothesis is two-tailed test. We know that when we reject the null hypothesis, then we consider the alternative hypothesis. If I using the symbols in the alternative hypothesis, that is a greater than or less than, then it is a one-tailed test. Means I am using the one-tailed test. If I am using the not equal to symbol while defining the alternative hypothesis, then it is a two-tailed test. So here we concentrate on the alternate hypothesis, because null hypothesis is a default, it is in general. But in case of alternative hypothesis, we represent it using some operators, less than, greater than, not equal to. So this greater than is nothing but the left tail test. Sorry, greater than is nothing but the right tail test. Greater than is nothing but the right tail test. When I am using the symbol greater than in the alternate hypothesis, then I will use right tail test. When I am using the less than symbol in the alternative hypothesis, then it is a left tailed test. When I am using not equal to symbol in the alternative hypothesis, then it is a two-tailed test. So in alternative hypothesis, I specify the direction, whether it is a left or right. In case of two-tailed test, I will not specify the direction. I will not specify the direction. For example, first I will give the example. Suppose in null hypothesis, I write that the marks of the student is equal to 60. In null hypothesis, that is in H0. So what is opposite to the null hypothesis? I will suppose write average marks of the student are less than 60. So here I am using the word less than 60. So it is nothing but the left tailed test. I am using the left tailed test. Same, if I alternate hypothesis, I use the word it is greater than 60. Average marks of the student, it is greater than 60, means I am using the right tailed test. When I will not specify the direction, means I am telling that alternative hypothesis, the marks of the students are not equal to 60. Means I don't know whether marks are greater than 60 or less than 60, but it is not equal to 60. So it is a two-tailed test. It is a two-tailed test. So the one-tailed test is a directional test. I will specify the direction, whether it's left or right, and it is a non-directional. Here I am not specify any direction, but whether it is a greater than or less than. So in a hypothesis testing, I can use the word like in case of left, I will use the word less, lower, below, decrease, like this. I will use these words. Absentee decreases the marks. Absentee decreases the term work of the student. In right tail test, while declaring the alternative hypothesis, I will use the word like increases. Presentee increases the term work marks of the student. Then above marks, above, more. So I will use these words, less, high, these words while declaring the alternative hypothesis in right tail test. Here I will not use that type of words. I will use the only word that is not equal to, not same, not significant. So this is a two-tailed test. I will show this by using the graph like this. Suppose this is a graph and we already discussed that we use the significance alpha while calculating the critical value. So enter level of significance, that is alpha is placed on one side. If it is a right tail test, so alpha is here. And normally this value is 5%. Normally this value is 5%. It is maybe 1%. It is given in the example. So this region is called as rejection region. This region is called as a rejection region. If it is a right tail test, it is a left tail test. So it is on left side. This is a rejection region. Left tail test. That's why left portion is rejected. It is a left tail test. Again I will draw the diagram for right. If alpha is here, it is a 5%, means 0.05. This is a rejection region. So rejection region is at right side, so it is a right tail test. This whole region is acceptance region. Acceptance. This is acceptance region. Acceptance means we are accepting the null hypothesis. We are accepting the null hypothesis. We are accepting the null hypothesis. So this is the acceptance of H0. This is acceptance region and this is the rejection region. So here I am writing rejection region is one side. If it is a right tail, rejection region is at right side. If it is a left tail, rejection region is at left side. Critical value is on one side. So this is a critical value. It is only either in left side or right side as per the test. If it is a right tail, critical region is at right side. If it is a left side, left tail test, critical region is at left side. Clear this point? Now same for two tail, I will draw the diagram. Suppose my level of significance, that is a value of alpha is 5%. So for two tail test, I will divide this 5 into equal parts, that is a 2.5%. So my critical region is on both sides equally distributed. So it is a 2.5% and this is again 2.5%. So it is a left side also, it is a right side also. This is acceptance region where I can, if my value is in acceptance region, then I will accept the null hypothesis. If it is in this region, means I will rejecting the null hypothesis, means I am accepting the alternative hypothesis. So this is a rejection region. This is the rejection region. So this is one tail test of two types, a right tail test and left tail test. Two tail test is a only one test having no direction. Example, average marks of student, if it is greater than 60, so it is a right tail test. If it is less than 60, it is a left tail test. All this is in a alternate hypothesis. If it is not equal to 60, then it is a two tail test. So as per this test, we use the distribution table. T distribution table for T test, chi-square distribution table for chi-square test. Value, critical value is depend on this alpha and the degree of freedom. So alpha for one tail test is suppose 5%, that means it is 0.05, and alpha for the two tail test, it is a half of 5%, so it is 0.025. It is a half of 5%. So rejection region is both the sides in case of two tail test. This is a rejection region also and this is a rejection region. Our value should be here only for acceptance. Here value is only one side. Here is the acceptance region. This is a rejection region. Here this is a rejection region and this is acceptance region. So this is a one tail test and two tail test. These are the ways for using the hypothesis testing. We are using these two types of tests as per our problem statement, as per our operators. Which operators we are using in the defining the alternative hypothesis. As per this operators, I will use whether it is a one tail test or two tail test. So I will use the formula, that is I will use here value alpha as a 0.05 and here value 0.025. So this is all about the one tail test and the two tail test. Thank you.